Okay, now methods of preparation of carboxylic acid. How to prepare carboxylic acid in the laboratory? So first method, number one, already you have got this reaction by oxidation of alcohols. By oxidation of alcohols. And also aldehyde. Alcohols and aldehyde. This is your alcohol RCH2OH. When alcohol undergo oxidation in presence of strong oxidizing agent like potassium permanganate, if you apply weak, then you will get aldehyde. So if you apply strong, directly it will convert it to carboxylic acid RCOOH. So this is one of the method. From alcohol you can prepare carboxylic acid. Similarly, if you take one aldehyde RCHO, this is your aldehyde. When aldehyde undergo oxidation in presence of some oxidizing agent, then it will also convert it to carboxylic acid. So this is the first method of preparation of carboxylic acid. By doing oxidation of aldehyde and ketone, you can prepare carboxylic acid. The second method, from alkyl benzene. From alkyl benzene. Alkyl benzene means like methyl benzene, ethyl benzene, that type of alkyl benzene you have to take. If you take methyl benzene, which is also called toluene, when you do oxidation in presence of one strong oxidizing agent potassium permanganate and potassium hydroxide in presence of sulfuric acid, then this alkyl group undergo oxidation and it will convert it to carboxylic acid like this. You will get the benzoic acid. You will get benzoic acid. Similarly, this is ethyl benzene. If you apply potassium permanganate and potassium hydroxide in presence of sulfuric acid, here 2 carbon present, but although 2 carbon or 3 carbon present, you will get 1 carbon above the benzene ring. I mean, again you will get the benzoic acid. So whether it contains 2 carbon or 3 carbon, but above benzene you will get 1 carbon. After oxidation, another carbon will form the side product. So this is another method to prepare the carboxylic acid by doing oxidation. By applying some strong oxidizing agent, the alkyl benzene, you can directly convert it to carboxylic acid. Number 3 method, by hydrolysis of nitriles. By hydrolysis of nitrile. Nitrile means the cyanide compound, CN group. When some organic compound contains CN group, that type of compounds are called nitrile. CN is also called cyanide. Actually, cyanide is the common name. Nitrile is IUPAC. This is one of the example of alkyl cyanide. When you do hydrolysis of cyanide, already you have got this reaction in presence of some acid, then it will convert it to carboxylic acid. Cyanide always converted to carboxylic acid on hydrolysis. Side product you will get ammonia, NH3. For example, if you apply CH3CN, which is called ethane nitrile, 2 carbon present, that's why ethane nitrile. This is the IUPAC name, and common name methyl cyanide. When you do hydrolysis, here 2 carbon present, that's why you will get 2 carbon carboxylic acid, CH3COH, acetic acid or ethanoic acid as the product you will get. So this is number 3 method of preparation. From cyanide you can prepare carboxylic acid by doing hydrolysis. Hydrolysis means addition of water in presence of acid. Number 4, from Grignard reagent. From Grignard reagent. You know Grignard reagent formula is RMgX. When it reacts with carbon dioxide, I mean Grignard reagent, you have to react with carbon dioxide, then it will convert like this. It will form one intermediate, and when you hydrolysis of this intermediate, it will convert it to carboxylic acid, RCOOH. If you are not understanding the reaction, I can explain. RMgX. In RMgX, R is minus, Mgx is plus. Carbon dioxide is like this, CO2. It has linear structure and carbon oxygen carrying double bond. Since oxygen is electronegative, more electronegative than carbon, so oxygen attract the bonded electron towards itself. That's why oxygen become delta minus, carbon become delta plus. I mean some electromeric effect takes place here, oxygen minus. And due to positive carbon, the negative will attack to the carbon and double bond is shifted towards the oxygen. After that, the R will be joined with carbon. This double bond remains same. Here R will be joined, double bond is converted to single bond, O become minus, that's why Mgx plus will be joined with it, which is the intermediate one. Now when you apply water in presence of acid, water produce two ion, H plus and OH minus ion. This Mgx plus, this positive ion replaced by the H plus ion, and you will get the carboxylic acid like this. So Mgx will be replaced by the H plus ion, and this Mgx combined with this OH, it produces the side product MgOHX. So this is your carboxylic acid. Actually the reaction mechanism is like this. So this is number 4 method. Number 5 method. Number 5 method, by hydrolysis of esters. You know ester? Ester is the sweet smelling organic compound. Ester is like this, RCOOR. COOR, this is called ester functional group. When you do hydrolysis, I mean addition of water in presence of acid, this reaction is reversible. So water gives H plus and OH minus ion, so it will break here. OH minus will join with it, H plus will join with it, it produces RCOOH and it produces ROH alcohol. That is why the product will be RCOOH plus ROH. So like this way also you can prepare carboxylic acid by doing hydrolysis of ester. Now the last method, number 6, by hydrolysis of 1,1,1 trihalides. This is one example of 1,1,1 trihalides, CHCl3, which is called chloroform. CHCl3, which is called chloroform. When you apply potassium hydroxide aqueous, then chlorine will be replaced by OH. You will get 3 OH group like this. But when a carbon contains more than one OH group, then the compound become unstable and it will break like this. This bond come from this to this bond will break. I mean this H plus ion combined with OH minus ion, it produces water, and the remaining part HC double bond O OH, which gives the carboxylic acid side product water. So these are the methods of preparation of carboxylic acid. Thank you.